I'm here in the Applied Labs in the Industrial Design Engineering faculty at the TU Delft with Mr. Ford over there. Last time we spoke, I was in Bangladesh doing some research on local materials and local craftsmanship techniques. I visited workshops, I visited villages, I spoke with people and communities, and all of this because of DELTAP project. DELTAP project aims indeed to reduce the exposure of these people in rural areas in India and Bangladesh to arsenic contaminant water. They don't have means to filter this water, and therefore they don't have drinkable water. So the project that is held by the Industrial Design Engineering and Civil Engineering faculty aims to create systems to reduce the impact of contaminant water. After the collection of the insights over there in Bangladesh in the field, together with our partners, for example Ruet, the University of Rajshahi, and the EPRC, so the Environmental Population Research Center, we came back, of course, to the Netherlands, and we gave us a brief, basically. So to design a household filter with the attention to what we've done before. So paying attention to local available materials in Bangladesh, but also the recycle aspects. So we decided to use an extruder with cap bottles to produce some parts for some components of the filter itself, and we did, of course, a lot of exploration, and I can show you. Actually, Mr. Ford is gonna do that. So Mr. Ford, please explain a bit what we've done with the... There you go, Mr. Ford.
Hello. Well, I'm here to explain to you what we've done with the extruder. We have one in the lab just over here. And we collected as much HDPE plastic as we possibly could. A lot of it was bottle caps, and other parts were just old washing domestic consumer goods from the university, from our friends, from all over the place, to get as much as we can. We then grinded up and shredded all the plastic once we'd already separated them. And once we'd organized the colors and then shredded everything, that's essentially the paint to use to make the products that you see before you here. These are all just experiments because it's quite a craft-based approach to plastic extrusion. It's kind of like 3D printing, but really you have to use, this is one of our molds, you have to use a mold. The extrusion would come out here, and it's a case of just rotating and then curing the plastic as it coils up the form. And yeah, these are some of our explorations. We've got experimentations with color and realizing that we've got problems with other plastics that are not compatible with HDPE. Mixing with reds and blue gives you purple. What we've been really trying to do is actually make something that can hold the weight and take the force of holding. It's only gravity, but there's also water involved, so it's and they're 2 5-litre bottles, so it's quite a lot of weight. And this I could pull apart quite easily if I wanted to. And then when you scale up and work on bigger sizes, the plastic cures and cools down quicker than you'd like it to, so you actually do have to work quite meticulously and quite quickly.
So yeah, now we showed everything of this, but we didn't say anything about the design, so it's maybe nice if we can introduce the design, the final design as well, and explain a little bit what we've done.
Sure, that's a really good idea.
Let's go. So we actually find a good place with a white background to fix it, put it there.
Yep. Hello everybody, this is the latest iteration of the prototype that we've made for the water filtration system. And I'm going to explain the flow and the process in each individual component. So in here,
this is going to go in a household, so it's meant for a family to provide water for about half a day. Can be refilled. It has a flow of about 1 liter per hour, just to give an idea on how much water can it filter.
Great, thank you, Federico.
Sorry.
So in here, this is a 5-litre water bottle that would be filled at the tap, which would have a high contamination of arsenic into it. In this second vessel, we have a rope, and the rope acts as a biocarrier to allow bacteria to grow, which aids in the filtration process. So what happens is they would pour the water into here. The next thing on the list is this vessel, which we made from extruded recycled plastic HDPE. The water would then travel down here to this point here. Each component and fixture of this design, we've tried to use extruded plastic to utilize as much as possible. So the contaminated water would travel along this pipe up here and into the top of this bottle here, which is a 1.5 litre Coca-Cola bottle. This acts as a rapid sand filter where we've got sand here.
Actually, it's in there. If it focuses, don't think you can see it. Nope, but we can see just the underside there.
Yeah.
But believe there's sand in there.
So both sand and anthracite. Anthracite is coal essentially, we would allow the water to pass through and fill up the vessel. Once it gets to this point, it should become pretty static, and then from then on, we have to use this valve here to control the velocity. That would then go through the entire system. The water, this pipe is not long, it's low, so that when the water drips, it is aerated. So instead of having it trickle through right down the middle, you want the water level to be completely constant, so there's an even filtration of the water. Once it gets to this point, it then goes up to here. This level should be parallel with the water level to remain at constant velocity, and yeah, and then it would just filter down here and into this.
And into the...
Again, we've got some rope here and another extruded plastic vessel. This rope will be jute in Bangladesh, and we are hoping that it can act as a insulation system so that this water will be kept cool, because Bangladesh has quite a hot and humid climate. Overall, we've done a few different iterations and tests. To see if the system actually, see if the concept works. We put 150 micrograms of arsenic into this 5 litre bottle, so it's 150 micrograms per litre. And then when we measured the outcome, we did 3 different tests. When we measured the outcome over here, we were getting a range between 35 to 45 micrograms. And Bangladesh's limit is, maximum limit for arsenic contamination in any drinking water is 50 micrograms. So it is technically safe to drink in Bangladesh. Why it's in a cabinet is so that this can be closed up to prevent any children and or animals getting access to the inside, which is also why it's off the ground.
Yeah.
So yeah, that's the design.
That's it. We are back in the lab. So just to tell you, wrap it up a little bit and tell you that next time you see our faces, we're gonna be in Bangladesh. We're gonna leave in a couple of weeks and hopefully be able to reproduce all we've tested and created over here as well over there.
So be sure to keep looking at the DELTAP journal, because we'll be uploading more videos, more pictures and more blogs about our process and our interaction and experience in Bangladesh. See you.
Ciao.